Welcome. In this video I'm gonna show you how you can obtain a one sample rank biserial correlation coefficient using R. I'm using Jupyter Notebook, but the R code should also work in, for example, R Studio. The version of R that I'm running is 4.3 and I have the basic packages installed by default. This is an effect size measure usually. It's actually for the one sample and paired samples, it's the difference in the sum of the ranks of the scores that were above the hypothesized median and those that were below it as a proportion of the total sum of all ranks. For an independent samples test, like the Mann-Whitney-U test, the formula is actually slightly different, but I'll have a separate videos on those. To show you how this can be done, I'll need some example data, so I'll load in a file called the GSS, General Social Survey from 2012, and then adjust it slightly for these examples. I actually don't need all the data, I just need one ordinal field from there. So I'm going to be using the account psi. I'm going to store that as an ordinal field, which has the responses to how scientific do you think accounting is. So for example, 348 people thought it was not too scientific. I also store the possible options as a vector in order under coding. I have a separate video on how you can actually do this with my stikpet R library, which simply has one function for it and then it returns the value. But if you don't want to use my library, there's another library, effect size, that can actually do this. However, this does require that the data is factorized, or at least has numbers in them. So I can change it by using factor and then use as numeric. Then I can actually load the library and then set a hypothesized median, and then finally can use their rank biserial function, and it returns a few different effect sizes actually, but one of the first one is the rank biserial. Now if you don't want to use any libraries, then first of all I'm going to remove all the missing values by using the NA omit. Then I'm going to determine the difference between the scores and the hypothesized median, but also if it was positive or negative. So I'm going to store that under diffs and signs. Then I can use the rank function of those absolute differences. So that's under there. And then I need the sum of the ranks of those that were above. So that means the sign equals a 1. That means it was positive difference, and the ones that were below have a negative difference, and I'm just going to sum those. The total sum of ranks is then those two added up, and that gives us these three values. We can fill out the formula from king and medium. That looks perhaps a little bit tricky, but this t is nothing else than the minimum of those two that we saw earlier, of the r plus and the r minus actually. And the rest we all have. The number of ranks is actually the number of scores that is not equal to the hypothesized median. And that gives us 0.43. We can use the simpler version from Curiton, and as you will see, that gives the exact same result. Alright, I hope this video was helpful, and thank you for watching.